So today we're going to talk a little bit about polar equations. Now, the thing about polar equations, you want to think about basically the unit circle. So for polar, you have a radius and an angle theta. And you can get back to your rectangular coordinates just by using the unit circle. So opposite your theta is your y, and adjacent is your x. So if you use basic SOHCAHTOA, you have sine of theta is our opposite over hypotenuse, which is just y over r. So our y is just r sine theta. So if you ever want to get back to actual rectangular coordinates, you can get y by taking r times sine of theta. And you can get x, very similar. X will be the cosine because it's the adjacent side. Now, a couple of the rules we have here is that tangent of theta is y over x. Now this is working more direction from you have x and y and you want to find theta. So you do like tangent inverse. But you can do the same thing over here. But you don't know theta originally if you just have like the order pair 1, 3. So if you want to go into polar, you have to find theta. You're going to just use y over x, tangent inverse. Also, if you want to find r, one of the easiest ways is using the Pythagorean theorem. X squared plus y squared equals r squared. Alright, so we convert the following points to rectangular coordinates. Now before we do that, we should think about where this really is. So what this means is you have a radius of 5 and an angle of pi. So I can do this without really going through the whole process here. So that means that I'm 5 out, so 1, 2, 3, 4, 5, and you start on the positive x-axis just like normally, and then you rotate about pi. So if we realize that, it would be 5 to the left. So this should be negative 5, comma 0. Now if you apply your same formulas here, your x is going to be r cosine theta, so r is 5 cosine of pi. Cosine pi is negative 1, and that gives you the x value of negative 5. If you do r sine theta, so y equals r5 sine of pi, well, sine of pi is 0, and you've got it. Now, problem like b, it's a little bit hard to do this just by eyeballing it. So 2 root 3 is somewhere here on the right, bigger than 2. I'm not really sure exactly where it would be. You can come up with a decimal if you'd like to. And up somewhere pi over 6. So something about right in that range. However, it's really kind of hard to eyeball it. I mean, I know which quadrant it should be in, but I don't have much more. So that's where our formulas come in. So your x is r cosine theta. So we take r, which is 2 root 3, cosine of pi over 6. One of the fun things about calculus is, you might not have needed cosine of pi over 6 up until this point, and now all of a sudden you got, what is cosine of pi over 6? What is cosine of 30? Well, if you don't know your unit circle very well, you could always just draw on your 30, 60, 90 triangle. And cosine is your adjacent. Well, 30 goes with 1, 60 goes with root 3, and 90 goes with 2. If you are going to use a 30, 60, 90 triangle, make sure you're drawing it in the correct quadrant, because if you're in quadrant 2, cosine should be negative. So anyway, cosine of pi over 6, which ends up being 30, is adjacent over hypotenuse, so root 3 over 2. So we got 2 root 3 times root 3 over 2, which gives us 3. So we got 3, which definitely looks, plausible here. And then we want our y, which is r, 2 root 3 sine of pi over 6. Now 30, if the cosine is root 3 over 2, then sine is going to be 1/2. So we get 2 root 3 times 1/2. 2's are going to cancel. We got 3 root 3, which also looks like it's probable, which is what we've got. If we want to move in the other direction, you need a radius and you need an angle. So the radius is probably the easiest one to go after first, and r squared is going to be just x squared plus y squared. So we've got 25 plus 25, so r squared equals 50, so we end up with a 5 root 2. comma something. So this is r comma theta. We need theta. Well, that's where we're going to go with it. Now, now that you have r, you could use either of these to find theta as well, but I think tangent of theta is the easiest. So tangent of theta equals, well, y over x. So our y is negative 5 over x, negative 5. And tangent is always the same, always 1 at all the power 4s. So I can use arctangent, second tangent, negative 1. And you got to be a little bit careful though, because tangent is negative in 2 different quadrants. So all students take calculus, right? So if I use my calculator, it's going to give me negative 45 in this quadrant here. However, that's not true. I need this to be in the, well, negative 5, third quadrant. Oh, sorry, it'll tell us the first quadrant because this will end up being a positive 1. So the answer in the calculator will be 45. But you have to be careful about your angle if you're going to use arctangent, because I need this to be in the third quadrant. Well, the answer is going to be 45, but 45 in the third quadrant, so 180 plus 45 is 225, or 5 pi over 4. And you always want to write these in terms of radians. So if you have to think of them in your head in terms of degrees and turn them back into radians, that's really up to you. And this next one, easier to do just by graphing it out. So 0, negative 2, down here. So my radius is 2, radius always from the center. And my theta is pi over 2, 2 pi over 2, 3 pi over 2. So 2, 3 pi over 2. There's a couple things that you could do to be a little sneaky. You can have a negative radius on these. And negative radius would start over here on the left. So like if I had negative 2 and then pi over 2, that would actually graph me the same thing. So it would go left and then down, or you can think of going up pi over 2 and then flipping it down. So there are some sneakiness things that you can do to this to make it work. And I've never really seen anyone work with these negative radians, but I don't see why you couldn't have 2 comma negative pi over 2. I'll think about that a little bit more, but the most common normal way would be to write it this way right here. So as far as graphing polar equations go, we got a lot of different things we can do. And one of the things that we can do is, well, just think of them logically. All it's going to mean is r is equals of 4. So it's not telling anything about theta, so this means you have a radius of 4, and theta can range from 0 to 2 pi, or keep going. Just a circle. So in polar equations, circles are incredibly easy. You want a circle with a radius like 12, just say r equals 12, and you've got it. Alright. Number 4, it tells us that theta equals pi over 4. So pi over 4 is up here at the 45-degree angle, right? But the radius could be here at like 2, it could be here at 1, it could be here at 12, it could be here at negative 3. Oh. So horizontal line y equals x. And don't forget, you can always go back and write this in terms of x's and y's. And it might be hard for you to do it first, but if you really wanted to, you can go backwards. Alright, let's try the next one. 2 cosecant of theta. Alright, at first it doesn't seem really to give us much in the way of doing this by hand, but if we were to rewrite this as r equals 2 over sine of theta, multiply both sides by sine of theta, and we end up getting 2 equals r sine theta. Now, at first, if this is the first time you've been seeing this, you probably don't recognize this yet. That's why. The line y equals 2. So it's up here at 2. Horizontal. Nice and easy like. Alright. Next one's one of my favorites, and r equals 2 theta. Okay, well let's just try to do this kind of more by points. So if theta equals 0, the radius is 0. And if as theta gets bigger, r is going to get bigger. So as you start going around here at pi over 2, the radius is going to be pi? Well, like 3.14 along the lines. So here somewhere. So what's ending up doing is as it goes bigger, as theta gets bigger, radius is going to get bigger. And you end up making a spiral. Now this has got a name. I believe it's Archimedes spiral. Don't quote me on that. It's always fun when you put something on YouTube. But it ends up being a spiral, and it's pretty cool. And if you want the spiral to be tighter, if you want to try this out, you can mess around with this on the calculator. And I'll show you how to do the calculator for the next problem. And you can really do anything that's in terms of r equals. You can do it in the calculator. It's kind of fun to mess with things like r equals like 0.1 theta. And maybe even expanding windows. You can kind of like make that whole spirally looking thing. So some of these you can use logic for, and other ones you can do things like plot points. So things along the lines of, in this next one, if I want to start with 0, well, 4 times 0 is 0. Cosine of 0 is 1. So at 0, we're going to have a radius of 2. Okay. Well, I've got a 4 in here, so if I think about pi over 4, this ends up being, so if I try to plug in pi over 4, which puts me up in this area here, well, the 4's cancel out, ends up being cosine of pi, which is 0, and then times 2 is still 0, so up in here, I kind of expect my radius to be back down to 0. So it's hard to tell what it's going to do, but I've got some points. I might have to plot points in between there to really get this. So anytime that you have, you're out of your depth in one of these, just the same thing with parametric, you can go to the calculator. So let's bring up our calculator here, and we'll see what it can do.